The enduring human spirit of curiosity has driven some of the most remarkable feats in history, but there's something even more fascinating in our past triumphs, something alive and ongoing in the cold, infinite expanse of space. This brave spacecraft is not just miles, but millions and millions of miles from its launch point. And yet, against all odds, it continues to send invaluable data back to Earth. What's truly remarkable is that it does this using technology older than that of a cassette player. Imagine that for a moment. A machine launched in the late 1970s, armed with primitive computing power and basic communication systems by today's standards, still operating, still sending home whispers across the vast cosmic sea. It was built in an era when rotary phones were still common, the internet didn't exist, and the idea of a home computer was still a novelty. And yet, the spacecraft launched in 1977 has just made a discovery so compelling, so profoundly mysterious, that it is shaking the scientific community to its core. It has captured the attention of the entire world, igniting both scientific debates and public imagination in equal measure. What could this amazing find in the far reaches of space possibly be? And perhaps more intriguingly, what does it mean for us here on Earth? There was a key moment in history, an inflection point, when two of the most extraordinary space missions ever launched by humankind ushered in a brand new era of exploration. These were not merely missions, they were odysseys, journeys into the unknown, carrying humanity's curiosity beyond anything we had previously imagined. This revolutionary turning point was made possible thanks to the brilliant and forward-thinking mind of Gary Flandro, an engineer at NASA's Jet Propulsion Laboratory. With nothing more than a pencil, paper, and a 20th century engineering mindset, Flandro made a startling discovery. During the late 1970s and early 1980s, an extraordinarily rare and favorable planetary alignment was due to occur, one that happens only once every 176 years. This alignment involved the four gas giants, Jupiter, Saturn, Uranus, and Neptune. In this rare cosmic configuration, they would position themselves like celestial beads strung on an invisible necklace, with Earth dangling at one end. This cosmic dance was no small matter. It offered a chance to use the gravitational pull of each planet to accelerate a spacecraft journey, a technique known as a gravity assist or gravitational slingshot. The concept was elegant. A spacecraft would swing close to a planet, steal a bit of its orbital momentum, and slingshot away at a higher speed, like being pulled along by an invisible rope. This maneuver could drastically reduce travel time through the solar system. A journey from Earth to Neptune that might normally take 30 years could instead be accomplished in just 12. This wasn't just clever engineering. It was a once-in-a-lifetime opportunity. Literally, NASA knew it had to act fast. And so, with incredible speed and precision, they launched two identical spacecraft, Voyager 1 and Voyager 2, during the summer of 1977, only 15 days apart. Their mission, to take advantage of this rare cosmic window and explore the outer planets in a way that had never been done before. No one at NASA could have predicted what these twin explorers would ultimately achieve. More than 45 years after their launch, both Voyager 1 and Voyager 2 remain operational, still sending back data, still pushing the boundaries of human reach. They are now the farthest human-made objects in history, having traveled far beyond what was originally imagined. Their mission, intended to last just 4 years, has stretched into nearly half a century. From the very beginning, these spacecraft defied expectations, delivering astonishing close-up images of Jupiter and Saturn's moons and revealing worlds that were dynamic, complex, and teeming with activity. We discovered moons with volcanoes, vast frozen plains, and mysterious atmospheres, places that were anything but the dead, frozen spheres we once imagined. Voyager 2 achieved historic first of its own. In 1986, it became the first spacecraft to approach Uranus, and 3 years later, it repeated this feat with Neptune, giving humanity its first ever close-up look at the ice giants. Before these encounters, Uranus and Neptune had been little more than blurry, featureless orbs glimpsed through Earth's telescopes. Voyager 2's journey transformed speculation into knowledge, revealing the striking beauty and complexity of these remote planets. By the time it had traveled more than 14 billion kilometers from Earth, Voyager 2 had boldly gone where no probe had gone before. Despite their modest size, comparable to a Volkswagen Beetle, the Voyager survived the harsh conditions of deep space. and continued to expand the boundaries of our understanding. Their voyage began with a maneuver around Venus, using its gravity to gain speed, a feat never before attempted by any spacecraft bound for Mercury, which cemented their status as trailblazers. To reach Jupiter, the Voyagers had to travel a distance more than 10 times the stretch from Earth to Mercury, passing through the dangerous asteroid belt along the way. Though Pioneer 10 and 11 had braved the celestial minefield before, the achievement was still monumental. Onboard intelligence was limited. Each Voyager carried computers with a mere 69 kilobytes of memory, a fraction of what even the simplest smartphone holds today. Data was recorded on track tape recorders before being transmitted to Earth using a 23-watt transmitter, about the same power as a household light bulb. Communications were made possible by 12-foot diameter satellite dishes beaming radio waves across unimaginable distances. But every day, the challenge grew. The Voyagers moved 3 to 4 light seconds farther from Earth daily, making the time delay in communications longer and longer. Eventually, signals took more than 18 hours to arrive. On top of this, background noise from Earth, radio towers, televisions, cell phones began to interfere with the faint messages trickling in from the edge of the solar system. And yet, the Voyagers endured. They continued transmitting data, unveiling unexpected phenomena in the interstellar void and consistently surprising scientists. Their mission had become more than a scientific success. It was a symbol of human persistence and ingenuity. Beyond our solar system lies the Oort cloud, a vast, distant shell of icy objects loosely bound by the sun's gravity and extending toward the nearest stars. The Voyagers have not yet reached it, but they cross into true interstellar space when they pass the heliopause, the outer boundary of the heliosphere, where the solar wind and magnetic field give way to the interstellar medium. But then something strange happened. As Voyager 1's signal moved beyond the familiar bubble of the sun's influence, Earth's instruments began returning fragmented readings that defied explanation. Gravimetric data fluctuated as if space-time itself was shifting. Magnetometers recorded patterns that resembled neural activity more than cosmic radiation. The deep space network, normally precise to the microsecond, suffered inexplicable delays and echoes, as if its own transmissions were being mirrored back by something intelligent in the dark. In the control room at NASA's Jet Propulsion Laboratory, silence fell. Engineers and scientists, once casually monitoring the routine pings from interstellar space, now stared at incomprehensible data scrolling across their screens. One of them whispered a word no one wanted to speak aloud: response. For a signal, no matter how garbled, to return with such precision, it suggested interpretation. It suggested intent. In the days that followed, Voyager 1 plotted coordinates revealed the impossible. Rather than continuing along a predicted path through the heliopause, it had veered sharply, not because of gravity, but as if something had taken hold of it and deliberately changed its course. Even more disturbing, telemetry showed it was accelerating. There were no gravitational slingshots available, no nearby planets or stars, and the solar wind's influence was long gone. Yet, the probe was gaining speed, heading into an uncharted region, a dark patch of space astronomers called a black fold, a place so devoid of starlight it was once thought to be nothing at all. Theoretical physicists scrambled for answers. Some suggested dark matter fluctuations. Others proposed exotic distortions in the fabric of space-time. None of the models fit. Something had taken Voyager 1. Something had reached out and pulled it in. And then the real shock came. Voyager 1's imaging system, thought long dead, suddenly powered back on. Not only was it active, it was transmitting images. The first was a blur, a swirling field of black and iridescent colors, like oil on water under polarized light. The second was clearer, a structure, suspended in the void, vast and faintly glowing. It looked like a cathedral made of crystal and shadow, its towering spires stretching into the dark like antennae or tendrils. Pulses of light moved along its surface in rhythmic waves, almost as if it were breathing. It was not a natural formation. Its symmetry was too precise, its form too deliberate. The probe drew closer. Earth scientists and millions watching around the globe were transfixed. No one knew what to call it at first. Some named it the locus, others a sentinel. But one name stuck, the eye, because in one particular image, the structure looked like a vast, unblinking eye staring into the camera. And then, silence. Voyager 1 vanished from all telemetry. The last image it sent remains one of the most mysterious photographs in human history. Humanity stood at the brink of a new epoch. For decades, we had searched the cosmos with radio telescopes, scanned the skies for distant planets, and sent probes to the edges of the solar system. Yet all of it had been driven by the same quiet question. Are we alone? The Voyager missions had been our messengers, our bottles cast into the cosmic ocean, carrying greetings in dozens of languages, music, and images of life on Earth. But no one truly expected a reply. Not like this. In the days after Voyager 1's final image, the scientific community entered a strange limbo. Part disbelief, part obsession. Specialists in data analysis pored over the last transmission frame by frame, pixel by pixel, hoping to find some hidden clue in the crystalline spires of the eye. Others were skeptical, calling it a glitch, an artifact of a dying system. But the patterns on its surface, the pulses of light, the intricate geometry, they seemed too deliberate to dismiss. Governments quietly convened meetings behind closed doors.